But in my view, you can't understand memory unless you can say why some people remember more than others. You can't understand learning unless you can say why some people learn faster than others. You can't understand attention unless you can say why some people can pay attention better than others. So individual differences is actually key. And it's a very hard thing to get across. A couple of years ago, some of us were at a meeting at Cold Spring Harbor. Yeah. And I had the great opportunity to sit next to Eric Kandel at dinner. Eric Kandel is a Nobel Prize winner in memory. And very well known, he's in his 80s, very dynamic and charismatic. And so I said, so Eric, what about individual differences? Why do some people remember more than others? And he put his arm around my shoulder and he said, Booby, don't go there. If you want to raise individual differences, you'll set the study of memory back 50 years. And of course I said, I think it's the opposite. I think, you can't understand memory unless you understand individual differences. And naturally, he has the Nobel Prize, he wins. But it was actually very interesting for me to have that conversation and see that perspective, which is the common perspective in cognitive psychology. And there are some cognitive psychologists now who are interested in intelligence because they think they can increase it. And I'm very skeptical about these studies. However, I would point out that all of you who study intelligence, whether you know it or not, are studying intelligence in the service of the end game, which is to increase intelligence. That's the end of intelligence research, is when we can take some people with mental retardation and increase their IQs. When we can take somebody with an IQ of 130 and make it 145. That's how we'll know we understand intelligence, in my view.
All those studies, when that happens, Rich, what do you think? Are we going to expand individual differences in achievement?
I think what we're going to do is shift the normal distribution to the right.
But are we going to expand the variance simultaneously?
It's an empirical question. I don't know. But I do like to talk in my public lectures about the IQ pill, which is metaphorical for our ability to increase IQ. And I always ask the audience, how many of you would take the pill if there were no side effects? So by show of hands here, if we could increase your IQ by a standard deviation with a pill that had no side effects, how many people would want to take it? Almost everybody. In public audiences, hardly a hand goes up. You're shocked and so am I. But I've had this conversation in public audiences. A couple of years ago, I was giving public lectures in 8 different cities in Spain at science museums. So we had kind of a high-end public discussion of this, and nobody would really publicly say they wanted higher IQ. This is after I explained what a standard deviation is, after I explained the importance of G in everyday life, and still people weren't enthusiastic. And then I would say, well, what about your children? Wouldn't you want your children to take this pill? Equal silence. And then I say, okay, I got 2 pills. You can only have one. One will increase your IQ and the other will increase your charisma. Everybody wanted the charisma pill. Now maybe it's my age, and maybe a little bit more charisma is not going to help me so much, because I would take that IQ pill in a heartbeat. I mean, to experience the world as Einstein experienced it, an IQ of 150 or higher, wouldn't this be a great thing? Or wouldn't it be a great thing to shift the whole curve to the right? Wouldn't it be a great thing to be able to treat some forms of mental retardation? This is why we study intelligence. This is the goal, in my view.
You're probably familiar with Carl Breiter's article, IQ and Elitism, where he says IQ is like money. Everyone says it doesn't matter publicly, but privately we all want more.
Sure. You all know from your experience the harshest critics of intelligence and IQ testing are in academia. And any of you who have ever been to a faculty meeting where they discuss hiring somebody knows the only thing they care about is how smart the person is. I mean, really, it is an astounding disparity.
Rich, you obviously think the field should do a number of things to move things along in terms of advancing knowledge about intelligence. What role would you see this organization, ISIR, playing in doing that?
I would like to see the organization be a little aggressive when papers are published about intelligence that have fundamental errors in them, mostly around psychometrics. Because there are many people outside of the field who publish articles about intelligence where they use various intelligence tests as outcome measures, and they appear not to understand that IQ points are not like degrees of temperature. I mean, everybody in this room understands that at a really basic level. But I think you'd be surprised with how many other scientists from outside the field don't get that. And there's a lot of there are a lot of bad papers in the literature on this, and we are basically silent about this in a formal way. So, you know, in political campaigns, when your opponent goes out and says something really nasty about you, whether it's true or not, the other side has a war room, and within an hour, the journalists are getting tweets and emails counteracting that. And I would like to see a more aggressive posture on papers that have fundamental flaws, especially papers published in high-end journals like Science and the Proceedings of the National Academy of Sciences. When papers get in those journals about intelligence that are fundamentally flawed, and we all have a list, I think the society should say something, either a letter to the editor just pointing out that the reviewers didn't understand this, or something. And the idea would be to educate people from outside the field who would like to contribute to the field about, you know, some basic concepts that will help them generate, you know, important and interesting papers. So that would be one thing. I think what the society is doing in terms of bringing students in is extremely important. And I like some of the ideas that have been discussed earlier today about getting the press more involved, being able to tell the, you know, the intelligence research has drama, it has controversy, and it has mystery. It really does. And those are things that should be appealing to journalists who like to write about these things.
You spend a lot of time thinking about cultures, too, for learning and work, and a lot of people listening to you now have spent most of their time in psychology departments or departments in the more social end of the intellectual spectrum. We have people here who study the sociology of intelligence all the way down to the genes. You spent most of your time in a medical school. Tell people about what that was like as opposed to a typical psychology department, and the pluses and minuses associated with that.
It was a Faustian bargain. I got access to brain imaging, and they got my soul. And I wouldn't recommend it for the faint-hearted. You got to be pretty tough in a medical school. It's not an academic environment. Especially in the medical school at Irvine, there are academic physicians, and then there are a lot of clinical people who do the clinical work. And in some academic medical schools, the ratio is 50-50 or more academic physicians than clinical. In our medical school, we only had a handful of academic physicians, and most of the chairs would not be chairs at real academic medical schools because they weren't researchers, they were clinicians. So this environment was very difficult for a PhD to navigate. And I was on soft money the whole time. I was evaluated with the same criteria for tenure as tenured faculty. I was promised a tenured position when I got there, which never materialized. And then I always had the choice of, well, I could get out of here and give up my access to imaging, move my family and have all that uproar, or I can just, take all the negatives, and there are many, in the service of getting the imaging. Getting the imaging was the most important thing. Some of you may be surprised to know, some of you who know some of the publications I've done, I never had more than one research assistant, and I never had any graduate students. This was the medical model. And I had the biggest chunk of my grant was always my own salary. And then the next biggest chunk, of course, was the very expensive imaging. So there was virtually never anything left to build a group, to build a lab. And that was the biggest long-term problem. But nonetheless, we were able to generate a lot of interesting imaging papers on intelligence because we were there first. Nobody else was doing it. So almost everything we did was kind of new and interesting and surprising from a scientific point of view. We never found anything we expected to find. And then later on, I got very lucky in having collaborators like Rex Jung and Roberto Cullum, Sharif Karama. These are preeminent imaging people. And the secret is you always got to hang out with people smarter than you are. And if you have a chance to hire people, you want to hire people who are smarter than you, but don't know it. That's the best. And so I've been very lucky in hanging out with really smart people. Imaging is not for the faint-hearted. It's a tough thing.
That's funny. That's exactly what Tom Bouchard said.
Oh yeah.
Except he didn't add the caveat about not knowing it. He just wanted them smarter. Rich, looking back, what do you consider your most significant contribution to the field of intelligence?
I think probably what most people know is the 1988 paper doing PET scans on people taking the Raven's advanced progressive matrices and the result of inverse correlations between glucose metabolism in the brain and scores on the Ravens. What people don't often understand about that paper is we had control groups of people doing attention tests, and compared to people doing attention tests, there were areas of the brain that were activated in the people doing the Ravens. And that's where most cognitive people would stop, but we took the extra step of correlating the amount of activation in those areas with the scores they got on the Ravens, and they were all negative. They were inverse correlations. So this led to the brain efficiency hypothesis of intelligence. So that early finding really set a course of trying to understand what we meant by brain efficiency, whether that was something about individual neurons or synapses or the connections among brain areas, and we're still working on that. And then the second thing was the paper that Rex and I published that he wrote most of in 2007 on the parieto-frontal integration theory of intelligence, where we claim we now have a model of the specific brain areas involved in intelligence based on a review of all the intelligence imaging studies up to that point. And since 2007, there are about another, we reviewed 37 studies for that paper. And there are now, since 2007, about another 100 imaging papers of intelligence. That's the geometric growth of brain imaging intelligence studies. So those are the two things, but the general thing is pressing the idea that not all brains work the same. This is what I really hope to be known for some days, that not all brains work the same way. There are individual differences. We study the individual differences on the psychometric or behavioral end, but they come from individual differences in the brain. Now, how the brains get that way, that's an interesting story. We don't know that story in any detail. But whenever you find a correlation between some brain parameter measured by brain imaging and a psychometric test, that's evidence for individual differences. There's variance. So if everyone's hippocampus activated the same amount when they memorized 10 things, there'd be no variance, there'd be no correlation. But some people activate more than others, some people remember more than others. So individual differences in the way brains work. Not all brains work the same, and we are now trying to quantify brain images to show how brains don't work the same, and then try to profile that, just like an MMPI profile, and then try to understand in a profile analysis way how brain parameters are related to intelligence. And I'll actually show an example of using very new kinds of brain imaging to measure information flow around the brain and how we think that will predict psychometric intelligence and how we can quantify these individual differences in the brain now. We're really at a really interesting period of brain imaging technology. We can now do things that we couldn't do with PET scanning or with fMRI. Those things are really old and antiquated, believe it or not. The new stuff that you'll see, I think you'll find quite interesting.
Now, this could be a little different. With respect to your career, what are you proudest of?
Proudest of my collaborations with some of the folks I named, and I'm also proud to be associated with people in this association, because we're all share not only an interest in intelligence research, but we're all dedicated to work in a field that is not regarded as a mainstream, that has many difficulties associated with it, but we all persevere nonetheless. And so I'm very proud that there's a whole group of people that I can kind of hang out with and talk to about this stuff.
So, something that's oftentimes helpful to younger academics is when people at your level comment upon their professional regrets. What are your?
I regret not having had graduate students. I regret not having built a team of people so that instead of years between papers, there would be months between papers. I regret those things. On the other hand, I haven't lost any sleep over them. I mean, I did make the Faustian bargain. And if I hadn't done that, I wouldn't have had the access to imaging that I had. And I had it early when nobody knew what they were doing. And so I had to learn a lot of things that I'd never imagined I would have to learn about positrons hitting electrons and 2 gamma ray photons being given off at a 180-degree angle, and about the way protons spin around the axis and how you put them in a magnetic field and you snap them in and out of alignment, and this is how you make an MRI image. And I know a lot of stuff like that I never thought I would have to know. But it's all in the service of trying to figure out something about intelligence.
Who were the people who inspired you along the way, or your heroes?
Heroes, I was inspired a lot. I was very lucky. I got to talk to Hans Eysenck on many occasions. I got to talk to Art Jensen on many occasions. Those of you who have had these opportunities, you cherish them. These are extremely intelligent, brilliant people who were very gracious with their time, and they just were nonstop researchers and advocates. And they were inspiring to be around.
What advice do you have for young academics just starting out?
Well, the most important advice I can give you by far, and it's easy to say, but it's very hard for you to do, is you never, ever take anything personally, even when it clearly is. I cannot, my wife will tell you, as many difficulties as I had in the context of a medical school, I never lost any sleep over it. I just accepted it. This was the kind of the price of doing business, and this is the way you have to do it. And if you take it personally, you will get nowhere. So you just kind of say, well, thanks very much, see you next time. And that's the end of it. So you don't take anything personally. I know it's very hard. I mean, it's easy to say, but you all know what I mean. So next time you really get insulted by something, by a bad review, oh, I got such stupid reviews on my grants. You know, they were unbelievably stupid. Why are you wasting money with a control group? You know, honest to God, that level. You say, how, you just say, okay, I mean, they're just dumb. I mean, I can't, that's the only way you can deal with it. You just, have to move on. So there's that. And the other thing is you have to be persistent in the face of all the difficulties you're going to face. So you get a bad review, you don't get the grant, you just have to kind of keep trying. You send it off to a journal and you get some dumb review that makes no sense, or you get a review that's actually very constructive and helpful. You just kind of keep at it and you don't give up, because you always remember what you're doing is really noble. You're trying to figure out one of the most complex things in the universe. I have said before that intelligence research is most similar to cosmology, to people who study the universe. It's a big question about intelligence, but also cosmologists are quintessential individual difference people. So when's the last time you saw a group average photograph of a black hole? They don't think like, let's average all the black holes we know about together to see the average black hole. It makes no sense. All black holes are bound by the laws of physics, but they're all different. And so you categorize them just like we want to categorize brains. And so I look to the field of cosmology whenever I need to be inspired, especially about individual differences. I'm sure if people who make their living studying black holes heard me say it's just like intelligence research, I don't think they would get it. But that's kind of how I think about it.
Well, Rich, I think at this point, what we typically do is just open it up for questions from the audience. We have a microphone here, and I would just like to invite people from the audience up to the microphone if they have any questions for Rich, and fire away.
I'm shocked. It's just like the IQ thing.
I have a question. Is this on? Can you hear me?
Yeah,
Yeah, it seems to be on.
Oh, it is on?
it's on now.
All right. I was going to ask you about that 1988 paper. I don't think you got the degree of respect that you should have for that paper from the general brain imaging community. And how has that affected you, and what do you think about that?
I believe you are correct. I have some stories about that. I'm just hesitating because I don't think it's appropriate to tell them publicly. But there were a number of imaging people who were quite annoyed. They were doing activation studies. They expected the brain to be activated during activation studies. I was saying something about deactivation. And there were people who said to me, this is impossible. You can't have deactivation. These are activation studies. Well, of course, the brain is in a constant ebb and flow of excitation and inhibition. So the idea that if you activate the brain to do something, that there would be no areas of deactivation is just silly. Of course there would be. And it took a while for some other groups to understand. Well, there were some people who only looked at the absolute difference between two conditions. They didn't care whether it was a positive or negative difference. They just thought, well, it's a change. We're interested in the change in the brain. And so I had to press very hard that sometimes when I would review papers, they wouldn't mention whether there were any inverse correlations, just not mentioned one way or the other. And sure enough, whenever I would press it and they would come back with a revision, well, there were these inverse correlations, but we didn't know what to say about them, so we didn't say anything about them. I mean, the whole field is, I'll tell you something else about the brain imaging field. In the early days, when you do MRIs, radiologists read your MRI of the brain from the feet up. So your brain slice, the right side of that slice is really your left hemisphere, and vice versa. With PET scanning, it was always right is right and left is left. PET scanning came first. Then some people wrote some programs to help analyze images. And they wanted to flip the radiological convention, making it right is right and left is left to make it easier. So they put a flip in the program, but it was a secret flip. Nobody knew it was there. So I believe, I can't prove this, but I believe half the papers published in the first years of MRI have right and left backwards. Just to give you an idea. I mean, the early days, it was the Wild West, let me tell you. It really was.
Oh, thank you. I'd like to add an anecdote about Eric Kandel, which is parallel to your comment. He was invited to comment on intelligence research for a Peter Jennings program on IQ some years ago. And I recall in his little segment, he said, look, you can actually see the synapses grow or something like that. You know? And of course, he was studying the neurons of the giant sea slug, as I believe, which is not noted for individual differences in G. And so I wrote a long comment about that program, which is posted someplace on the web, I understand, and pointed out that his comment had little to do with the study of human intelligence, because we study individual differences and what brings them about, and he wasn't doing that. And in trying to prepare that, I wrote to the two commentators. One was a famous black surgeon at Johns Hopkins Hospital who was on the program, and the other was Kandel, asking them some questions about the context of their comments on the program. Kandel never replied to me. The black surgeon, who was a very gracious man, did, and enabled me to place some of his remarks on the program in their proper context. He commented, someone asked him what affects intelligence, and he said, well, you know, dehydration and this, that, and the other thing, you know. And I pointed out that these were perfectly solid textbook answers, but very few people suffer from dehydration when they're taking IQ tests, and that's not a major source of individual differences. And Kandel didn't reply, and I always suspected that was for political, self-interested reasons, because that was before he won the Nobel Prize. And he was probably leery of stirring up any angry constituency at that point. The other thing is your comment about mobilizing to respond to poor research in important outlets as a society, and there should be something like a war room. This reminded me of some discussions many years back about having something like a science Supreme Court to settle major scientific controversies. And all I kept thinking about at that time was, who would pack that court? And how would you decide who would be on it? And I see the same problem for your war room suggestion. I could imagine even within this society there could be a war within the war room. And And therefore, it's really incumbent on individuals like yourself, perhaps, and maybe some of the rest of us who aren't too lazy, to try to rise to the occasion and respond as individuals on those occasions, because mobilizing a group for a public controversy can be a very difficult thing to do, even though it has its appealing possibilities. Thank you.
Sure.
Robert?
Here's a naive question, but to what extent do you interpret brain behavior correlations causally?
What was the last word?
Causally,
Oh, causally.
in the direction from brain to behavior?
Well, they're correlations, we don't know. But if you believe that a particular network is involved in G-related problem solving, you can do an experiment to turn that network up or down, either with drugs or with transcranial magnetic stimulation. So you have to take it the next step from correlations to experimentation. And we now have technologies that allow human experimentation where you can temporarily, I don't want to say turn on and off, but you can temporarily interfere with brain processing. And if you have kind of a hypothesis-driven, this is the network we want to tweak a little bit and see what happens, I think that's an interesting stage of intelligence research that's actually beginning. You see it a little bit with accelerated learning, delivering 1 to 2 milliamp current shocks to the brain while people are learning things. And there's some evidence that they learn faster. And it's not a conditioning thing, by the way. It's actually shocking the brain. And there's some, we were talking earlier with some people about implanting some electrodes just inside the scalp to deliver electric shocks during problem solving. And you can do this in combination with brain imaging. There are a lot of interesting ways to begin to study the causality. So I think the combination of imaging with genetics has been very powerful. There have been some extremely interesting papers in the last couple of years, mostly coming from the collaborations that are organized by Paul Thompson at UCLA, where they are doing brain imaging in twins along with DNA sequencing. And they have found common genes for white matter integrity and psychometric intelligence with large N's with replication in independent samples. So, the combination of imaging and genetics is very powerful. You add in sophisticated psychometric extraction of G from test batteries with confirmatory factor analysis and structural equation modeling, and we have all the tools we need to really start answering some fundamental questions about where in the brain is intelligence, how is it that intelligence comes from the brain, what are the parameters, and how can we tweak it? Because remember, I want to be able to say, here's how we can increase it. So there are a lot of interesting things. I just want to say one more thing about that before I forget. One of the most interesting television series that I have seen, a few years ago on HBO, a dramatization of the Apollo space program to get a man on the moon. It's called From the Earth to the Moon. And I highly recommend that you all get this and watch all 8 episodes. They're hour episodes. If you're really interested in science and how things really get done, and teamwork in science and technology. And there's a scene in one of these episodes where the head of the astronaut program calls the 16, this is post the original 7 astronauts. There's about 16 astronauts, new astronauts. And he calls them into a room and he says, we have the go-ahead for the Apollo mission and we have some intelligence that the Russians are having difficulty. And so we are going to get to the moon first, which means that a person standing in this room is going to be the first human being to walk on the moon. Can you imagine that if you were one of the people standing there? I mean, that's a real moment. And I think that we are going to have some real breakthroughs in understanding intelligence very soon. And it's very likely that the people who are going to make those breakthroughs are sitting in this room right now. And I'm extremely happy about that. It makes me really optimistic about the future of intelligence research and this society in particular.
Well, my question actually relates to Robert's question, and it has a developmental dimension. In your view, what are the most important aspects of the development of the brain that we would have to understand if we would be able to understand individual differences in intelligence, and also what you said before, to become able to change it?
Okay. It looks like the imaging data, especially the imaging data combined with the genetic data, is pointing to the integrity of white matter connections. And you're going to hear about that in our brain imaging symposium over the next couple of days. So the integrity of white matter in terms of its ability to transmit information around the brain, especially specific brain areas. I think that's going to be a very important thing. It seems to be under genetic control, and there seems to be a developmental sequence to it. That, along with structural aspects of gray matter, and by that I mean either cortical thickness or the volume of gray matter, again, seems to have seems to be under genetic control and seems to have a developmental sequence. There are very powerful brain imaging studies of intelligence done in children in a number of places, and some of those sample sizes are 200 and 300. And it shows sex differences. It shows that boys and girls' developmental path, white matter and gray matter, are different. I mean, so there's a lot of kind of churning out there. And what exactly the developmental influences are, we don't know. But I can't tell you that they're 100% biological. So that even if there's some even if there's some environmental factor, like the number of words spoken in the household by age 6 months, which research has shown is crucial for subsequent language development in terms of the auditory areas developing to perceive the sounds of a language. It's very fascinating work. And there's also work that shows the average number of words spoken in a household varies dramatically according to social economic status. So in homes with welfare mothers, it's like 600 words an hour. In upper middle class families, it's like 2,100 words an hour. I mean, there's big differences. And if that turns out to have an impact on brain development that subsequently impacts intelligence, that's a kind of an environmental influence, but it has its influence by impacting brain development. So it's a biological mechanism. And we don't know, I don't think we're close to knowing what these things are yet.
Let's do one more question.
Elliot Tucker-Drop here. I was struck by your comment that the end goal is to shift the distribution to the right. It made me think of some writings by Jim Flynn, in which he made the metaphor that intelligence is like money. It doesn't matter how much you have in absolute terms. It matters whether or not you have more than everyone else around you. And I was wondering about your thoughts about that.
I like it. I mean, Jim Flynn's a very interesting fellow. I mean, if you ever have a chance to talk to him, he's a very thoughtful fellow, and he has some, kind of creative views on this. But as long as, if you want to make the analogy of money, one of the most cynical and hurtful things I've ever heard is that if you took all the money in the world and divided it equally, in 6 months the same people would have it back. And I think that's a very cynical statement with an element of truth about intelligence in it, though. right now, I'll just say one more thing about that. Right now, all our measures of intelligence, by and large, are relative to other people. And I believe that Art Jensen was on the right path when he said we have to move beyond that. That G is a fact of nature, and to make intelligence research a natural science, we need to have a way to measure G that's not limited to our relative measures, that we need something like what he called mental chronometry, and the actual timing of information processing around the brain. And we now have the technology to do that. And I'm going to show some of that actually on Saturday. So I think we're moving in a very nice direction. At some point, the phenomenon that we're studying, you know, one of the professors at Hopkins used to say, Warren Torgerson, went to Warren Torgerson once with a question about significance levels. Warren Torgerson helped develop multidimensional scaling. He was a preeminent mathematical psychologist. And he listened and he said, well, you know, if what you're studying is big enough to be important, it's big enough for you to find without a significance test. You think about this. Global climate change. Think about climate change. Does this really depend on a P of 0.5 on some variable? No, you look out your window and you see the ocean coming into your house. That's what convinced people of climate change almost overnight. And I think we are on the verge of having brain measures that are real ratio measures in terms of milliseconds, where you can see millisecond by millisecond what the brain is doing throughout the brain as the person is solving G-loaded problems. And I think this gives us the opportunity for a new kind of definition of intelligence and moves us more toward making the study of intelligence more like a natural science, just like the study of black holes. And so that is a nice symmetry to bring us back to that.
Okay, and with that, Rich, I really want to thank you for coming here and being our guest. This has been fascinating, and you are one impressive guy. Thank you for coming.
Thank you. It's been an honor for me, and I thank you all for inviting me to do this.